Today's notes are on interval and inequality notation. You should have seen inequality notation before, but interval notation might be a little bit new. So let's do the old stuff first. It says inequality notation is a way of writing a subset of a number and uses the symbols less than, greater than, less than or equal to, and greater than or equal to. So we are going to have to memorize these notes. Less than, I'm going to go ahead and highlight the ones pointing to the left in pink. Less than and less than or equal to. Notice that they're both pointing to the left. However, one of them has an equal sign and the other one does not. And then the other ones that we're going to be working with are the greater than symbol and the greater than or equal to symbol. Again, the only difference separating those two is that there's an equal sign on top, on the bottom. So if a certain point is part of your set, we're going to use that equal sign, but we'll talk about it more as we go into it, okay? So here are the steps on how to write your set using inequality notation. First, we're going to identify the boundary points. The boundary points on your graph are going to be basically where the graph ends, okay? And they're usually defined by either a closed circle or an open circle. And again, we'll talk about those as we get to them. Step two, we're going to determine if the boundary points are part of your set. On a number line, if the boundary point is filled in, then it is part of your set and your inequality is going to need an equal sign on the bottom. So that's how you're going to know that you're going to need an equal sign like this or like this on the bottom. If the boundary point is not filled in or if it's empty, then it is not part of your set and you do not need an equal sign. So that means in that case, you're going to be using a symbol that looks like this with no equal sign or like this, again, with no equal sign. Step three, we're going to go ahead and write your variable x so that it is included in your set. I'll show you what that looks like in a bit. Remember that we always write our sets from our smallest number on the left to our largest number on the right. That's just usually the way we write stuff. Okay, so here we go. Here are three different examples. I'm going to go ahead and try to write each one of these sets using inequality notation. So first thing they're going to ask me is where are the boundary points? Where does my set start and where does it end? Well, I can tell by those dots that the boundary points are right here at -3 and right here at 1, right? Those are where it starts and where it ends. So I'm going to go ahead and say that my boundary points are -3 and -1. Sorry, I'm used to writing in blue. -3 and 1. Which ones are part of your sets? So what they're asking is, are they filled in? Are they not filled in? They are both filled in. So they are both part of my set. So I'm going to go ahead and write both of them are because the circles are filled in. That means I want -3 to be part of my set and I want 1 to be part of my set as well. I want both of those numbers. I'm going to write my set using inequality notation. Now, remember that when we're talking about inequalities, we're talking about all the x values that are shaded in. So I know that -3 is shaded in. So is -2, so is -1, so is 0, so is 0.5, so is 0.999, including 1. So these are all the x's right here that are part of your set. Notice that -3 is less than or equal to all your x's. So I'm going to write -3 is less than, but because the -3 is filled in, I'm going to put the equal sign in there. And I know that the largest number is going to be 1. So my x's need to be less than or equal to 1. Again, the equal sign because the circle is shaded in. And I know my x's need to be somewhere in between those. Can my x be -3? Yes, it can because the -3 is filled in. Can my x be 1? Absolutely. Can my x be 4? Nope, it's too far on my set. Notice that my x is got to be stuck between -3 and 1, and 4 is way the heck over here. Okay, so that's how we write this set using inequalities. All right, let's take a look at the next one. We're going to go a little bit faster. What are the boundary points? Well, the boundary points are where your set starts and where it ends. So I know my boundary points are going to be 1 and 4. Which one of those are part of your set? Well, notice that this time the 1 is not colored in, therefore 1 is not part of your set, okay? You can get really, really close to 1, like you can get 1.01, 1.001, 1.00001, but 1 itself does not work. Same thing with the 4. 4 does not work, but you can get close to the 4. You can pick 3.9, 3.999, 3.9999999. You just cannot pick the 4 itself. So I'm going to say that neither are part of your set. And my x's have to be between 1 and 4. So I can pick 2, I can pick 3, I can pick 2.5, right? So what is that going to look like? Well, I know that 1 needs to be less than my x. Notice I did not put an equal sign because 1 is not one of the values for x that I can pick. So do not put an equal sign there. Whenever this is empty, you leave it without an equal sign. And my x's also need to be less than 4. Notice that the x is stuck between the 1 and the 4, and the 1 doesn't work and the 4 doesn't work, so we do not put equal signs. All right, last one. What are the boundary points? Again, this time my set starts at 0 and it ends at 3, so my boundary points are 0 and 3. Which ones are part of your sets? Well, the 0 is filled in, but the 3 is not. And I know my x's are going to be somewhere stuck here, okay? So only the 0. That means when I do my 0, I need to put an equal sign underneath. So I'm going to say that 0 is less than or equal to x is less than 4. Notice that my x's are in between the 0 and the 4. X can be 0. X cannot be 4. Whoop, not 4, 3. Sorry. Sure, some of you guys saw that and said, what the heck is going on? Okay. All right, so that's how you use inequality notation. We're going to do the same thing, but this time we're going to use interval notation. Let me go ahead and use a different color. Interval notation is a way of writing a subset on a number line that uses symbols like brackets and parentheses. And I just realized I did not highlight inequality notation over here. Let me go ahead and do that right now. Okay, interval notation, we're going to be using brackets and parentheses. It's kind of the same idea, but the notation is going to be a little bit different. It's no longer going to look like this, but we're going to be using brackets and parentheses instead. And actually, it does make it a little bit faster. So your steps are almost the same. Step 1 is going to be to identify the boundary points, just like we did last time. Step 2 is going to be determine if the boundary points are part of your set, just like we did last time. On a number line, if the boundary point is filled in, then this is part of your set and you're going to use a bracket. If the boundary point is not filled in or empty, then it is not part of your set and it's going to need a parenthesis. So instead of a less than or a less than or equal to, we're going with a bracket or a parenthesis, okay? Step 3, write your interval notation with the corresponding brackets and parentheses for each boundary point. Remember that we always write our sets from smallest number on the left to the largest number on the right. So just like before, it's going to start very similar, okay? So it says, what are the boundary points? Well, we already said earlier that the -3 and the -1, and the +1 are my boundary points. Which ones are part of your sets? Both, just like last time. Remember, we said if it is part of your set, you're going to use brackets. If the dot is filled in, we're going to use brackets. So I want to catch all the numbers in this set. Remember, my x's are in here, and I want to catch all those x's. So I'm going to use my brackets, and I'm going to catch them, okay? So I'm going to fill it in this way because it's a bracket. And obviously, I'm not going to do this, right? Because it's not catching anything. I want to contain that set. So my bracket actually needs to go the other way, like that. So all you're going to do is, I'm just going to use my notations. I know that my set started at -3 and it ended at 1. On the -3, I needed a bracket. And at +1, I also needed a bracket. This is basically telling that my x's have to be somewhere between -3 and 1. You're going to picture like this on a number line, and your x has got to be in here. -3 works because the bracket's there. 1 works because the bracket's there. Okay, so we're going to include those. All right, on the next one, what are the boundary points? My boundary points are 1 and 4. I already did that above. 1 and 4, just like last time. Neither are part of your set because they have this empty. Now remember what we said. When it's empty, we are going to go ahead and try to catch those x's just like before, except you cannot include the 1. So you need to use a symbol that's smaller than that. So I'm going to use parentheses on the 1 because 1 does not work. And I'm going to use parentheses on the 4 because 4 doesn't work. Let me stretch that over. There we go. And so now that I have my picture, like I can go ahead and start this, right? From left to right, my first boundary point is 1. My second boundary point is 4. Because 1 does not work, I'm going to use parentheses. Because 4 does not work, I'm going to use parentheses. And again, this is basically saying, hey, use all the numbers between 1 and 4, but do not include the 1 because you have a parentheses, and don't include the 4 because of the parentheses, okay? So we're saying the exact same thing. We're just using a different notation for it. All right, last one. What are the boundary points? Well, I know the boundary points is 0 and 3. Which ones are part of your set? 0 only. That means on the 0, I'm going to need a bracket because it does work. But on the 3, because it doesn't work, I'm going to need a parentheses. So I'm going to go ahead and write my notation. I'm going to be using 0 to 3. On the 0, it's a bracket. On a 3, it's a parentheses. This says my x's are somewhere between 0 and 3. The 0 works. It's part of your set. The 3 does not work because the 3 is not filled in. All right, hopefully that made sense to you. And an interval notation is not bad once you understand what it is, but there are a couple of little special circumstances, so let's go over those right now. Number sets do not always have an endpoint. That is to say, often they will either continue towards infinity if it goes all the way towards the right, or negative infinity if it goes all the way towards the left. The following examples will show how we will adjust each type of for each type of scenario. I always have a little mistake here. Go ahead and write the word for. We will adjust for each type of scenario. All right. So on the first one, let's see, it says I have all these numbers and it looks like going from left to right. I'm going to look at the red one. It starts at -3 and this thing keeps going and going and going and it doesn't stop. So we're going to say that it goes towards positive infinity. Now, whenever you're dealing with the number infinity, okay, as it relates to interval notation, you cannot contain infinity. Infinity is an idea, it's not really an exact number. So I like to think of it as you can't really catch it, so we can't really include it. So as far as the -3, it says, notice from left to right that the set starts at the boundary point 3 and goes to infinity since it never ends. Using interval notation, we write, I know for the -3, we're not going to be able to catch it. It's not part of my set, so I'm going to use parentheses. And I'm going to put a little thought bubble here. Infinities always use parentheses. So we're going to go the other way like this. So how would I write that? Well, it starts at -3. It goes to infinity. -3 doesn't work, so I'm going to use parentheses, and you cannot contain infinity, so we're going to use parentheses on that end. Guys, if you see an infinity symbol, you're using a parentheses every single time, okay? For inequality notation, we have a set representing all the x's, all the numbers bigger than that should be a 3. Sorry, it's early, guys. I'm making little mistakes here. That should have been a +3. All right, so from 3 infinity, 3 to infinity, we're going to use parentheses. Now, as far as the inequality, I want all the x's, I remember my x's are over here, that are bigger than 3. So I need my x to be greater than that number 3. Is 3 going to work? No, because it's not filled in. So I'm going to write x needs to be greater than 3. Or you can also write that your 3 has to be less than x if you're going to do it going from left to right. Notice that your 3 is right here and your x's go to the right of it, okay? Both ways work. Technically, we usually write it like this because we like to write our variables first if it's only one set, okay? All right, what about for the other one? Same concept, except here, if I go from left to right, I notice that I'm starting at negative infinity. And it keeps, I have all these x's here, here, all the way up to my boundary point of 3. That is my boundary point on this side. Is 3 part of my set? Yes, so I'm going to put a bracket. And what did I say about infinities? That's a negative infinity. Students always forget to put the negative when it goes to the left. Be careful not to forget that. Remember, it's an infinity, so use a parentheses. So as far as interval notation is concerned, we're going to say it's all the numbers starting from negative infinity all the way up to 3. And you are going to include the 3 with a bracket because it has that dot is filled in. As far as how we read this for inequality notation, I want all the numbers that are less than 3. All of my x's here are less than 3, so you just write x needs to be less than 3. Does it need an equal sign? Absolutely, because there's the dot is filled in, so it is part of your set, so this wouldn't be correct. You need an equal sign underneath. You need all the x's that are less than or equal to 3 because that dot is filled in. All right, we're down to the last couple of examples. I'm going to give you one part of information and you need to figure out the rest. So we should be seeing it like this, 3 different examples. On the first one, it says that I'm starting at -4 and that dot is filled in, so I know I need a bracket. And when does it stop? It doesn't. So this is going to go on to infinity to the right, so I'm going to need a parentheses. So I pretty much already did the interval notation. I know it's going to start at -4 and it's going to continue going towards infinity. -4 needs a bracket because it's filled in. Infinities always have parentheses. As far as inequalities are concerned, these are all the x's that are greater than or equal to -4. I need an equal sign because that dot is filled in. So I need all the x's to be greater than or equal to -4. All right, on this next one, they gave me the interval notation. They say it goes from -2 to 6. So the way you want to graph these, you always want to graph them with an open circle first. Let's go ahead and circle our boundary points. It's going to be at -2 and at +6. Because the -2 has a parentheses, you do not shade it in. Because the 6 has a bracket, you do shade it in. And my x's have to be all the numbers in between. Okay, as far as the inequality is concerned, I do have a set that has boundary points. So it has a left boundary point and a right boundary point. So I'm going to go ahead and write those boundary points right now. I have a -2 on the left. I have a 6 on the right. I know I have my x's in between. Because -2 is not filled in, I don't want an equal sign on my inequality. So I'm going to say -2 needs to be less than x. Because the 6 is filled in, then I need my x's to be less than or equal to 6. So I'm going to write x is less than or equal to 6. And that finishes up that problem. And we got one more to go. This last one says my x's need to be less than 5. So I'm going to circle the boundary point. It's going to be at 5, always with an open circle first. And I need my x's to be less than 5. So it looks like there is no limit to how small my number can be. So all of these numbers over here going on forever. Be careful. What do we call this concept when it goes all the way to the left? We do not call it infinity. We call it negative infinity. Careful, careful, careful. Okay, so my boundary points are at negative infinity, which means there is no boundary point over there, and 5. As far as the negative infinity, that's always going to need a parentheses. And because the 5 is not filled in, we're going to need a parentheses on this side as well. So how do I write that using interval notation? Well, I know I'm going to start at negative infinity, and I'm going to go all the way up to 5. Infinities always have parentheses, and since it said it didn't have an equal sign, and it's not filled in, we need a parentheses right here. And that finishes up the notes for today. As always, if you have any questions, feel free to ask.